A giant egg explodes as part of a fireworks display. The egg is at rest before the explosion, and after the explosion, it breaks into two pieces, uh, with the piece B moving in the positive x direction. The masses of both pieces are indicated in figure 1, shown traveling in opposite directions. What is the magnitude of the momentum of piece A before the explosion? This is the giant egg. It explodes into two pieces, A and B, and then B travels along the positive x direction, A travels along the negative x direction after explosion. Okay. And before explosion, the egg is at rest. We are seeing, the egg is at rest before explosion. Here, the question is, what is the magnitude of the momentum of piece A before explosion? It is 0. Because before explosion, the egg is at rest. That is why the magnitude of the momentum of piece A before explosion is 0. This is a conceptual question, actually. Okay. Now, second bit. During the explosion, is the magnitude of the force of piece A on piece B greater than, less than, or equal to the magnitude of the force of piece B on piece A? It is equal to. Okay. Because these two forces are action-reaction forces. According to Newton's third law, action-reaction forces are equal in magnitude but opposite in direction. Okay. Whatever the force piece A applies on piece B, the same amount of force piece B applies on piece A. Therefore, they are equal. Okay. Next, the component of the momentum of piece B is measured to be plus 500 kilogram meter per second after the explosion. Find the component of the momentum of piece A after the explosion. Just now I told you FAB is equal to FBA. Am I right? And moreover, F is equal to delta P by delta T. If you want, I will explain how it is. We know Newton's second law, F is equal to ma. Am I right? Where F is the force, and then m is the mass, and then a is the acceleration. And then we know acceleration is equal to change in velocity over a period of time. Okay, so I will substitute this here. So F is equal to m times Vf minus Vi over delta t. Okay, here what is happening? Vf, and I will expand this one. So this will become mvf minus mvi divided by delta t. Or I can write it as F is equal to Pf minus Pi over delta t. And then Pf my here, mv momentum is equal to mv, no? Momentum is equal to, momentum P bar is equal to mv, mass times velocity. V is the velocity. Am I right? Here, mvf is the final momentum and mvi is the initial momentum. Okay. Therefore, mvf minus mvi is the change in momentum, and change in momentum is represented as delta P by delta T. I will write like this. F is equal to delta P by delta T. R F into delta T is equal to delta P, where delta P is the change in momentum. And F times delta T is called, this is called impulse. Okay, impulse J is equal to delta P. This is called impulse momentum theorem. Impulse momentum theorem. Okay, so therefore F is equal to delta P by delta T. Am I right? Here, what he is saying, the momentum of the piece B is measured to be plus 500 kilogram meter per second after explosion. Find the component of momentum of piece A after the explosion. So it will be the same, no, because both the forces are same. Am I right? FAB is equal to minus FBA. Therefore, PB, PAB except which he gave, no? So we have to find out PAXF. Am I right? PAXF is equal to minus 500 kilogram meter per second. Okay, so that the total momentum will be 0. Agree? So this is the answer for this question. Okay, this is just a conceptual question because the total momentum, the momentum of the system is conserved. Whether it is the this one, elastic collision, elastic or inelastic collision, moment in both the cases, the momentum is conserved. Momentum of the system is conserved because no external force is acting on the system. So the momentum of the system is conserved. So when the momentum of the system is conserved means the total momentum should be equal to 0. Okay. So if it is minus 500, then only it will become 0. So that is why the answer is we need not do any calculations. Simply, if we know the concept, we can answer this question. That's it. Okay. So hope this helps. Thank you. Bye bye.